Hi everybody, welcome to another video in Pre-Calculus, section 10.5, partial fraction decomposition. This technique is very important and has a lot of application, but none of that is at this level. If you go to Calculus 2 differential equation or higher level class, we use this a lot, so this is rather important. Right, before we, the purpose of the partial fraction is that we have one big fraction and just break it down to a bunch of little fractions. Something like this, where we have a fraction, break it down to a smaller fraction. Right, so before we do that, we just need to do some basic involving system of equation and factoring, also important. Right, of course we can do this by hand substitution, elimination, but later on we have more complicated problem, so I'm just going to use a calculator. So this is how we use a calculator. Right, so first what we do is we're going to put this in the matrix form, and that's called the augmented matrix. So put 1 and 2, the equal sign, just draw the vertical line, and then we write the number on the other side. Right, and then we do RREF. This is in the linear algebra. This is called reduce row echelon form. And if we do that, if the left hand side turn into the identity matrix, then what we have here will be the answer. What we have there will be the answer. Right, so I'm just going to put this in the calculator. So we have second matrix. There's maybe something here doesn't matter, but when you hit second in matrix, on the first tab under names, this is where all the matrices are listed, and we will record them from here. If we want to input it, have to be under edit. Let's edit matrix A. Right, 2 rows, 3 columns. Right, the coefficient 1, enter 2. We just enter the numbers. Right, once we're done, hit second quick, and then we hit second matrix again. Under names, you see that's a 2 by 3 matrix. If we hit enter, we will record the matrix, and that's what we have. Right, once again, second matrix. If we want to edit, go to edit, and then go up and down to edit matrix A or B or whatever it is. Right, what we need is the RREF. The RREF is in the second tab under math. Option is way down here. RREF. It's not REF, have to be RREF. And we hit second matrix again. Under names is A, so we call the matrix A. And that is what we have. -1 and 2. So when we have like that, the first row is X, the second row is Y, then the solution, the first one is X, the second one is Y. Right, so that's how we use the calculator to solve the system of equation. Right, we will go back and do a bunch of this later. Now factoring. Of course, that is just a factor, and to get x squared, we have to have an x. And to get -12 and add up to -4, so we can use -6 and 2. Okay. If we want to make sure when we type, when we graph the function, it will go through the point -2 and 6. Therefore, the factor is x minus 6 and x plus 2. So, if we solve it, x squared minus 4x minus 12 equal to 0. So we have x equal to -2 and x equal to 6. We have the theorem says that if these are the zeros, then x minus the zeros are the factors. And of course we have x plus 2 and x minus 6. Exactly that. Now, x cubed plus 27. If we do that, we only see -3. So we know one factor is -3. But that's all we have. This is actually a difference of 2 cubed. So if we have a difference of 2 cubed, it's going to be a minus b a squared plus ab plus b squared. And if we have a sum of 2 cubed, it's going to be a plus b a squared minus ab plus b squared. So that is the sum and difference of 2 cubed. What we see here is the first side of the factor we have the same sign. Next we have opposite sign as this, and the last one is positive. Right. So in this case, what we have is just x cubed plus 27. So x cubed plus 3 cubed, and we use the sum of 2 cubes. X plus 3, x squared minus 3x plus 9. 3 squared is 9, right? And now we have 16 is x to the, 2 to the 4th power. So we have a difference of actually just different 2 square. We don't have, if we have a square minus b square, it's going to be a minus b and a plus b. Yeah, there's no sum of 2 square, a square plus b square. We don't have the identity for that. Right, so even though it is true, but we can write x square and 2 square, or 4 square if you will. Right, here we use the difference of 2 square. We have x square minus 2 square and x square plus 2 square. Well, x square minus 2 square is x minus 2, x plus 2, and then x squared plus 2, just x squared plus 4. Right, so that's all we have. Now, so actually this is a theorem of a very, very high level. Let's say that all the polynomial can be factored in terms of quadratic and linear, meaning that doesn't matter what the polynomial is, we can always break it down into a linear factor of degree 1 or quadratic. So it doesn't matter what the polynomial is, it can be always be break down into, can be factored into quadratic and linear factor. If there's a qubit, it should be able to factor that to something smaller. Same thing for higher the degree, it will break down into linear or quadratic. Factor will be linear or quadratics. Right. So because of that, we can break down the partial fraction into these simple cases, 4 of them. The first case, when we have non-repeated linear factors. So if we have a fraction where the denominator can be factored by linear factors, then we just split the fraction into a little fraction where each factor is in the fraction of the where the denominator is just a constant. Notice that in terms of a fraction, the degree at the bottom have to be bigger than the top, otherwise we can't divide them and break it down smaller. So let's look at the first example and see what I mean by that. So I'll find the partial fraction of this. So first we can factor on x, and then we have x minus 1, right? Now, the partial fraction means, I'm just going to start with this. If the denominator is just factors of linear factors, then we have one of them is x, and the other one is x minus 1 at the denominator. Right, on the top, degrees on the top is always less than the bottom. So the top cannot have any x in it. If we have x on it, degree will be 1 or bigger. So we can only have a constant. So let's have a here and then b there. Next, we just need to determine b and a. That's simple, right? For here, what we do is we multiply by the least common denominator of them will be x and x minus 1. Right? Multiply everything by that. Multiply x and x minus 1 to this, x and x minus 1 cancel out, we only have 4 left. And multiply this x, a over x times that, the x and the x cancel out. We have a and x minus 1. Right? And now multiply this by x times x minus 1. X minus 1 cancel. We have bx. Right. Next, what we do is the method of undetermined coefficient. I'll just multiply this out. Ax minus a plus bx. Combine like terms. A plus b x and then minus a. On the right hand side is 4. Now the method of undetermined coefficient is this. If two polynomials are equal, then the same coefficient of the same degrees have to be equal. So we look at this. We have 4 on the left hand side. We do not have any x, right? So I'm just going to put 0x on the other side because there's no x on the other side. Now, same degrees have to have same coefficient. So we have a plus b is equal to 0. And the other equation, that constant negative a have to be equal to 4. So same degree, same coefficient. Now this is easy. We can a is negative 4, so substitute in there. We have negative 4 plus b is equal to 0, so b is equal to 4. Right? So we have that initial problem for x squared minus x equal to a over x. A is negative 4 over x plus 4, which is b over x minus 1. And that is a partial fraction. So it is simple enough, right? All we do was just factor the denominator completely, split them out into a little fraction, and then solve for the coefficient. Right. Now, so that is how we solve for the coefficient. The more common way, more direct. However, there's a trick for this. If we pay attention on this equation here, this is a trick. Sometimes it works if we have the simple factors like this. Now, for that, let's say if we choose x to be equal to 0, then we don't have this term, right? So at x equal to 0, we have 4 equal to a 0 minus 1 plus 0 x. Of course, 0 to x gone, and so here we have 4 equal to negative a, so a is equal to negative 4. Now, same thing. If we want to a to be 0, we're going to choose x to be 1, right? So in that case, that factor is gone. So to x equal to 1, we have 4 equal to a times 1 minus 1 plus b times 1. So a times 0 is 0, and we have 4 equal to b. Yeah, because if we do that, we don't have to do the multiply now and combine like terms, but we get the same thing. A is equal to negative 4, b equal to 4. So when the denominator is, when it is simple factors, we do that. It's linear factors. If it is quadratic, it might be a little bit complicated. Right. Next, let's look at this one. Of course, the first thing we need to factor. So how do we factor that? Let's see if the calculator can help. X cubed. Sorry. Minus x squared plus 4. Right. Negative 2, 1 and 1 and 2, right? So that definitely helps. So we have what? 2, negative 2, and 1 are zeros. So let's just write x equal to what? Negative 2, 1, and x equal to 2. Those are zeros. If those are zeros, then we will have the factors x minus those numbers. Because if we're not sure, we can always multiply it out. What I do here is I just want to factor by grouping. X cubed and x squared, just group the first two. We have x squared, x minus 1, and then minus 4, x minus 1. Now both of them have x minus 1. Factor it out, and then we have x squared minus 4 squared. X squared minus 4, sorry. X squared minus 4 is x squared minus 2 squared. Difference of 2 squared. We have x minus 1, and x squared minus 4 is x squared minus 2 squared, which is x minus 2 and x plus 2. Which is, of course, those are the factors we expect to get. Right, now we have the denominator factor completely, then we can split them. Right. We split them into little fractions. X minus 1, x minus 2, x plus 2. On the top have to be a constant. We cannot have x on the top because degree on top cannot be more than the bottom. Right. And then what we do here, of course, multiply by the common denominator. By the way, I'm going to do the system equation first because I said that more standard and more general. Later on, when things get complicated, it still works. This method here sometimes it works if the number is simple. When things get complicated, we won't be able to do that. Right, here once again multiply by the common denominator, x minus 1, x minus 2, x plus 2, right, on both sides. When we multiply that out, denominator cancel out, we have 2x minus 1 equal to, next, focus on the a terms. X minus 1 cancel out, we have x minus 2 and x plus 2. Now, focus on the b, the second one, x minus 2 cancel out. We have x minus 1, x plus 2. And then the last term, c, x plus 2 cancel out, x minus 1, x minus 2. Right. Now the rest is just multiply them out, combine like terms, and then solve for the coefficient. Right. Right. Now, multiply out the polynomial first. X squared, right, just want to multiply it out, plus 2x minus 2x minus 4 b x squared plus 2x minus x minus 3, minus 2, sorry. And then c x squared minus 2x minus x plus 2. Right. Combine like term, x squared minus 4 b x squared plus x minus 2. And c x squared minus 3x plus 2. Right. Just multiply them out. Ax squared minus 4a bx squared plus bx minus 2b cx squared minus 3bx 3cx, sorry, but still. Cx squared minus 3cx plus 2c. The other side is still 2x minus 1, of course. Now combine like terms. X squared, those are the terms we have. So a plus b plus c x squared and then x bx minus 3cx and then we just have negative 4a, negative 2b, and 2c. Negative 4a, negative 2b, and 2c. The right hand side is 2x minus 1. So now we just set up the system of equation. For x squared, a plus b plus c for x squared, do we have x squared on the other side? That will be no, so that will be equal to 0. Second, b minus 3c, on the other side we have 2x. So we match that with 2. And then finally negative 4a, negative 2b, and 2c equal to negative 1. Right, that's simple enough. Put in the matrix, reduce row echelon form. That's pretty much it. So 1, 1, 1, 0, 0, 1, negative 3. So no a, 1b, negative 3c, and negative 4, negative 2, 2, negative 1, 2. Right. Right, so put in the matrix. Let's go down to matrix B. 3 rows, 4 columns. Right, 1, 1, 1, 0, 0, 1, negative 3, 2, negative 4, negative 2, 2, negative 1. Second, more quick. Let's check again. Second matrix. Let's go down to matrix B. Right, enter it correctly. Now we just go to second matrix, reduce row echelon form, and apply to matrix B. Sorry, just go down to B. Okay, convert to fraction. Right. Now, I suppose A is that, B is that, and C is that. Now, I think we should check to make sure that it's actually correct before we continue, because this, even though simple, but could be tedious, and I may make a mistake somewhere, right? So, now let's focus on this here. What happens if we want to eliminate some of them? Of course, there are 3 factors. Why don't we just let 1 equal to 0, right? So at x equal to 1, what do we have? 1 put in for x. A 1 minus 2, 1 plus 2. B 1 minus 1, 1 plus 2. C 1 minus 1, 1 minus 2. Right. The nice thing is that 1 minus 1 is 0, minus 1 is 0. So we just have negative, 1 on this side, and on the other side we have negative 1 times 3, so negative 3a. So for this we have a equal to negative 1 over 3. Right. That sounds right. So that's the first one. So when we let, usually when we have the common denominator, let each factor equal to 0. Now let x minus 2 equal to 0, so x equal to 2. and I'm going to put 2 in here. Two minus 2, 2 plus 2, B 2 minus 1, 2 plus 2, and C 2 minus 1, 2 minus 2. Once again, we have a 2 minus 2 here, cancel out. Yeah. So when we just have linear factors like this method helps. So 2 minus 2, so that would be 3 on this side. And we have 2 minus 1 is 1, 2 plus 2 is 4, so we have 4b. Of course, we have b equal to 3 over 4. Of course, we can do the same thing, and we try for c, where we let x equal to -2, and that's the same thing. So that look right. Yeah. So when we have a linear factors, try something like this. It certainly works. Right, so we have a is that, b is that, and c is that. Right, and then we can put back and we write the original x cubed minus x squared minus 4x plus 4 equal to -1 over 3. Oh, that form, x minus 1. Yeah, this form. Plus b 3 over 4 x minus 2, and c is -5 over 12 x plus 2. Yeah, that's simple enough. When we have a linear factor, it's not that bad. Right. So this is one of those cases. If we have the linear factors, then we're going to have one fraction for each factor. Right. Now, second case. What happens if we have the repeated linear factor? Well, so when we have something that raised to the n to the power, so we'll raise some power. In that case, we still have the same factor, but we have to have n factors of that, so we have n fraction for that. You get the idea. Right. Actually, let's just do one example and you get the idea. Let's say if we have these scenarios, there are 2 factors of x and 3 factors of x minus 2 cubed, right? So what it says here is that if there are 2 factors of x, we're going to have 2 for that. One is x and one is x squared. Simple enough, right? X minus 2 cubed, so there are 3 of them, meaning we're going to have 3 factor, 3 fraction, x minus 2, and then just increasing the power 2, and x minus 2 cubed. Simple enough, right? Yeah, so it depends on the power. We're going to have the same number of fraction of increasing power. If it's x squared, we have x squared. If we have x to the 5th, we're going to have x squared, x cubed, x to the 4th, x to the 5th. Now, this one we have x minus 2 cubed. There will be 3 of them, first, second, and third power. Right, what do we put on the top? Well, just like what we have before, degree have to be less than the bottom, so this have to be a. Even though this is a x squared, but all of them will be the same. So just, yeah, whatever we put on the first one, I have the same degree on the second. So even though this have x squared, we still just put b, right? X minus 2, of course that's just c. Even though there's the power here, doesn't matter. Just put the constant, because we do not have any degree. So for the multiplicity like this, all of the top have to have the same degree. In this case, degree of 0 for all of them. So of course multiply out common denominator, combine like terms, solve for the coefficient. That sounds like a lot because we have 5 variables to solve for. Right. Okay. So just want to do this so to get the form of get the idea of what we need to do when we have these scenarios. Right. Now back to this simple example. Find the partial decomposition of that. So on up the bottom have x. I will factor that out. X squared plus 4x plus 4. On the top, x squared minus 4x plus 12. Right. Now, x squared plus 4x plus 4, what's that look like? Of course, you know we should have the repeated linear factors because that's what we have in this part of the section. But let's look at x squared plus 4x plus 4. Right. We see that the graph touches the x-axis as -2, meaning -2 is a 0. X minus -2 is a factor, so we're going to have x plus 2 is a factor. Multiplicity of 2 because that is touching the x-axis. Right. Now just break this out. We have x squared minus 4x plus 12. Even though the top we may or may not be able to factor, doesn't matter. Just factor the denominator and then split it out later. By the way, make sure that the degree on top is less than the bottom. That's what we should have. If not, if degree on top is equal or bigger than the bottom, we can always divide the top to the bottom. And then we just only decompose the remainder. Right. Have x and x plus 2 square. Right. One factor of x, and there should be 2 factors for x plus 2 to the first and then to the square. Degree on top has to be less than the bottom, so this is A, this is B, and for those two have to have the same degree. So that's what we have. Now what we do here, of course, multiply by the common denominator. Will be just that, right? When we multiply to the first term, the denominator cancel out, we just have the top. Now multiply by the first term here. X cancel out, we have A, x plus 2 square. And then when we multiply by the next term, we have B, x plus 2, cancel one of them, we have bx, x plus 2. And then the last one, C, x plus 2, square cancel out, Cx. Right? Multiply out, combine like terms. X plus 2 square, of course that equal to x squared plus 4x plus 4. Right? That's what we factor. So certainly we can just write that. Or we just multiply x plus 2 times x plus 2. Multiply this out. Bx squared plus 2bx plus cx. So ax to the fourth, ax squared 4ax, 4a, bx squared, 2bx, and cx. Now combine like terms. Ax squared, bx squared, a plus bx squared. For ax, 2bx, and cx. And factor out x. And 4a left by itself. On the other side, we still have x squared minus 4x plus 12. Right, now we just set up the system of equations. We have x squared on this side, so a plus b is equal to 1. 1x squared on the other side. A, 2b, and c equal to negative 4x, so we match that with negative 4, and 4a is 12. Right. This we can just do it by hand, but let's say if we use a calculator. By the way, if you're using the TI-84 and with the newest operating system, that means when you hit second, the plus sign and number 1 about the computer or about the calculator. If it is 2.55 MP, that is the newer operating system. In that case, hit mode and go down here and keep it at the math print. Alright, now we will do the reduced row echelon form. But now we can enter the matrix directly in the home screen. Hit alpha, zoom. This is, let's just write the matrix first. There's a lot of ways to solve this by hand easily. So this is the 3 rows and 4 columns matrix. Click OK. And most important here is whenever we enter the numbers, do not hit the enter. Use these arrows instead. So 1, next one, 1, 0, 1, 4, 2, 1, negative 4, 4, 0, 0, 0, and 12. We have 3, negative 2, and negative 12. By the way, if we don't have the identity matrix on the left hand side, so it is either no solution or infinitely many solutions. If we don't have this, 1 on the diagonals, 0 everywhere else, then either we have no solution or infinitely many solutions. In this section, you should not have that, because we should be able to decompose. So A is 3, B is negative 2, and C is negative 12. So we can decompose them as original problem, x squared minus 4x. And look at this one. A, B, and C. Right. That's simple enough. By the way, if we do this by hand, from here, obviously, we can solve for A. For A is 12, so A is 3. If A is 3, put 3 in here, we can solve for A, right? A plus 3 is equal to 1, so A is -2. And once we have A, once we have B, substitute in here, we can solve for C. So this one, certainly we can do it by hand. Right, how about we try the method we used before? We have x and x plus 2 as a factor, right? So let's choose x to be 0. When x equal to 0, we have 12 on this side, equal to A 0 plus 2 square, B 0 plus 2, and C times 0. Of course, this one gone, this one gone. 12 equal to 4A, so A is equal to 3. Simple enough. Right. Now also that we have a factor of x plus 2, so why don't we use x equal to -2? Some of them will cancel out. So put -2 on the left hand side. Right, A minus 2 plus 2 square, B minus 2 plus 2, and then C is times -2. Right. Once again, this go to 0, this go to 0. And on the left hand side, 4, 12 is 6. Right, so then we have 4 and 12, 16. Of 16 and 8, 24 equal to -2C, so C is equal to -12. Right, and then we run out of option, and then we say, how do we solve for B? Well, we already use factor of 0, factor of 1, factor of 0 and -2. Right, well, if we keep doing with this, we just need to solve for B, right? So of course we can choose anything that is simple. How about we choose 1 or -1? Right, I like -1. Actually, anything will work. And then put that in here, -1 square. Put that in -1 square minus 4 times -1 plus 12 equal to A -1 plus 2. Of course, you can choose any number, but the reason I choose -1 because this is just 1. B times -1 plus 2, and then C times -1. Alright, so -1 is 1, and 12, 13, 4, 17, 1, that's 17. On the right hand side, that is A, well, because -1 plus 2 is 1 square, so it's A. B times -1 times 1, so it's -B, and then -C. Of course, we have to substitute A in for 3 and C equal to -12 in here to solve for B. Right. So, of course, when we just take care of the factor, only 2 factors, so we can only solve for 2 of them. The last one, we can pick any value for x, substitute in there, and then substitute in for A and C as well. I should be able to find B, right? put a is 3 and c is negative 12 in here, we can solve for b. Alright, so that's the point. Right, so usually when we don't have all of number distinct linear factor, when we have the square, it's a little bit complicated, and we take a little more creative here to solve for it. Of course, like I said, you can choose x to be any number to solve for b, but of course that's different way to solve for the coefficient. The point here is how do we break it down. Once we know how to break it down, we can solve for it. Right, next, case number 3, where one of them could contain a linear or quadratic factor. What happens if we have a quadratic factor? Then it's fine, we will just break it down into quadratic factors. Right, now what we have here is the difference of 2 cubed, x cubed minus 2 cubed, and the difference of 2 cubed is x minus 2 x squared plus 2x plus 4, x squared plus 2x plus 2 squared, which is 4. We cannot break this down any further using real numbers. Of course, the way to confirm that is if we're going to graph x squared plus 2x plus 4, you can see that the graph go like that. It does not intercept the x-axis, so there's no real solution. Therefore we cannot factor using real numbers. Right, so that. So what happens if we have a quadratic factor? How do we break it down in partial fraction decomposition? Right, so the one factor of each, so we have one fraction for each. On the top, we can just have degree less than the bottom. So this one linear, so degree on top have to be 0, which is a constant. This one quadratic, degree on top will be 1 less than that, so it could be a linear function. Right. Now, for this, of course, we multiply by the common denominator on both sides. X minus 2 x squared plus 2x plus 4. And for this one, we cannot really use the method like we do in here, because for x squared plus 2x plus 4, we don't really need, we cannot choose any x values to make that one disappear. We can only choose x equal to negative, x equal to 2, but that's about it. It doesn't help much. So the method that when we choose some values for x and to solve for the coefficient work the best if we have all of them are linear factors and all of those factors are different. If there's repeated, like what we have here, it's not really convenient after all. Right. So that's why we said we just multiply it out, combine like terms. That method always works. Doesn't matter how complicated the factors are. Right. Now multiply it out. That cancels out. We have 1 a times that. A times that. X minus 2 cancel out. We have a and x squared plus 2x plus 4. Right. And now for that, x squared plus 2x plus 4 cancel out. We just have bx plus c times x minus 2. Right. I'll just multiply it out. Ax squared plus 2ax plus 4a. Right, multiply a to everything, and now multiply this out. Bx times x, bx squared minus 2bx plus cx minus 2. C. Right. Because we should not have any term that just a number by itself. All right. X squared plus 2ax plus 4a bx squared minus 2bx plus cx minus 2c. Right. Combine like terms. Square a plus b x square two ax minus 2bx and then the cx. Those are the x term. Factor out the x. We have 2a minus 2b and a c. And then we have 4a minus 2c. We have 1 on the left hand side. Right, then we can set up the system. Right, no x squared on the other side, so a plus b must be 0. No x on the left hand side either. That must be 0 as well. That's 1. So that's 1. Right, and then I put that in the matrix. 1, 1, 0, c equal to 0, 2, negative 2, 1, 0, 4, 0, negative 2, and 1. And reduce row echelon form. Alright. Second matrix, reduce row echelon form and alpha zoom. Right. 1. Again, don't hit enter here. Just hit next. Next. 2. Negative 2. 1. And 0. 4. 0. Negative 2. And 1. By the way, if we need to enter the negative sign, use this negative sign. Don't use subtract. Subtract is between the two numbers. Negative is just in front of a number, so use the negative sign. Okay. And we don't have any whole numbers here. 1 over 12, negative 1 over 12, and negative 1/3. Right. So with that, of course, we can just break it down. As a is equal to 1 over 12, b negative 1 over 12, and c is negative 1/3. So we break this down, and we have 1 over, copy the original problem, x cubed minus 8. And this is the breakdown. A 1 over 12 over x minus 2 plus x squared plus 2x plus 4. B is negative 1 over 12 x minus 1 over 3 for C. Right. Right. By the way, as mentioned before, when there's no linear factor, it will be difficult to choose the values to eliminate that. But we can do for one of them. For that, if we choose x equal to 2, this one disappears, right? So we have 1 equal to a. Now we use x equal to 2 to make this disappear, because there's a factor of x minus 2, so we choose x equal to 2. Right, 2 square, 2 times 2 plus 4 plus b times 2 plus c 2 minus 2. Right, so we put 2 in for x, because this factor cancel out, because 2 minus 2 is 0. And then 2 squared is 4, 4 and 4, so we have 1 equal to 12 times a, so a equal to 1 over 12. Well, at least we can check for a. And then next, so for b or c, if we put in numbers, it's not going to help much. Let's say if we choose x to be 0, for example, f1 equal to a, 0 square plus 2 times 0 plus 4 plus b times 0 plus c times 0 minus 2. Actually, that it does work, because work a little. That's for a. We know what a is. B times 0, or at least that one gone. C times negative 2, so minus 2 c. B is 112, so 1 equal to 4 times 112 equal to negative 2c. That is 1/3. And move over there, so we have 2/3 equal to negative 2c, and divide by negative 2, c is negative 1/3. So that is correct. Yeah. So there's some number we can choose, but it's not as convenient as before. If we have all of them linear factors and all the factors are distinct, choose the numbers. This is the best way we can simplify things. On this one, of course, we can choose any number. Sometimes it works out a little bit better, but it's not a way to go. This one, if we have the help of the calculator, multiply them out, combine like terms, should be reasonable. And it could get, if the problem get complicated, where we have the answer like this, the calculator doesn't worry about complicated numbers. Right. Next, x squared minus 2 over x squared plus 1 times x squared plus 3. The first thing we do is, when we look at this problem, make sure that it cannot be factored any further. If this problem is x squared minus 1 instead, or plus 1, then the first thing we do, we have to factor them completely. X squared minus 1 can be factored into x minus 1 and x plus 1. Right. The way to check for that is we just type, we just try to graph it, x squared plus 1, and if there is an intersection, there will be a 0. If there will be a real 0, there will be a factor. Since there's no intersection, no 0, no factor, meaning x squared plus 1 cannot be reduced any further using real numbers. Right, so same thing for x squared plus 3. So we know that this is irreducible. One of them is x squared plus 1. The other one is x squared plus 3. On the top, degree will have to be 1 less than the bottom. So we can put a linear function here and cx plus d. Right. And then we just multiply it out, everything by x squared plus 1, x squared plus 3. Right, multiplied by the common denominator, cancel out, we have x squared minus 2. Right, the first one, x squared plus 1, cancel out. and cx plus d times x squared plus 1. X squared plus 3 cancel out. Now we just multiply it out. Ax cubed plus 3ax bx squared 3b and then cx cubed cx plus dx squared and d. Right, combine our terms, right? Ax cubed and cx cubed, right? Factor out a and c. And we have bx squared and dx squared. Factor out x squared and then 3ax and the cx, factor out the x and then we're left with 3b and d. Right? On the other side is x squared minus 2. Right. Now we just match the coefficients. A plus c equal to no x cubed on this side, 0. B plus d, there's 1x squared here. 3a plus c there's no x here equal to 0. And then finally 3b plus d is equal to negative 2. Right, I'm just going to put everything in the calculator and do the reduced row echelon form. Even though there's a way to do that without the calculator, because this problem is simple enough. Right, just do the reduced row echelon form. Reduced row echelon form to the matrix has 4 rows, 4 columns. Right, 1, 1, 1, here's 1, and here's 1. Three and 1. 3, 1, and negative 2. So I have this negative 3 halves and 5 halves for B and D. Just going to put here. So we have b equal to negative 3/2 and c is equal to 5/2. Right, put that together, we will have x squared minus 2 over x squared plus 1, x squared plus 3. Right. Right, here we have a and c as 0 and c. Sorry, a and c as 0. B is negative 3/2 and D is 5/2. That's what we have over there. Right. So B is negative 3/2 and C is 5/2. Right. Of course, the best way to do this, of course, just multiply them out, combine like terms. So common denominator here we have x squared plus 1, x squared plus 3, and multiply this we have negative 3/2 times x squared plus 3 plus 5/2 x squared plus 1. Right, just multiply them out. I mean, just add them. So negative 3/2 x squared negative 9/2 x negative 9/2 plus 5/2 x squared plus 5/2. Of course, negative 3/2 plus 5/2 is an x squared. Negative 3/2 plus 5/2 is 1. And negative 9/2 plus 5/2 is minus 2. So yeah, of course, the best way to do this, to check, is just combine the fraction, and when they combine, indeed, they equal to that. Now, I did mention that there's a quicker way to do this by hand, by the way. If you look at this system, these two equations only have a and c, these two equations only have b and d. So instead of solving a system of 4 equations for unknown, we break this down into 2 systems, one of which is a plus c equal to 0, and 3a plus c equal to 0. And then the other system have b and d. B plus D is equal to 1, and 3B plus D is equal to negative 2. From this, it is obvious that the only thing that happened is A is equal to 0 and C equal to 0, because we have 0 on the right hand side. So A and C cannot be anything but 0. Right, and then we just need to solve for this, which is a 2 by 2 equation, 2 unknowns. Very simple. Right, but the bottom line is, like I said, this problem, without all the bell and whistle, depends where the problem could be simple or not. When we have the common denominator, when we break it down, multiply by a common denominator, multiply them out, combine like term, system equation, reduce through echelon form. That always works. For sometimes the problem is nice like this, yeah, we can use some other method, or sometimes when we have the linear factors like this, we can just choose some number and that works out nicely. If we have linear factors, that tend to work out better. It will work the best if all of those linear factors are different. And before we end the section, just case number 4, when we have this with the multiple quadratic. If there's 2 multiple of them, if there are 2 of them, we're just going to have 2 factor for that. With the increasing power from 1 to 2. If we have cube, we're going to have, if this is a cube, we're going to have 1 more. So that is the idea. But regards the power on the top, regards the power at the bottom, it still is just a linear function on the top. doesn't matter what the power is. All of those factors of the same factors, all of those fractions of the same factors, the top we have the same degree linear function in this case. Right. So of course usually this when we have more this we have a lot of variable to solve for. So that's why we don't do many examples in this case. But that's how we decompose a big fraction into a little fractions. And that we only learn the technique here. The application where we go to calculus 2 differential equation. If that on your in your major, then you see this again. But that's all I want to cover for partial fraction decomposition. As always, thank you for watching and see you in another video in pre-calculus.